Welcome all. These classes are targeted for GATE 2024. This is a series of SOM questions on for mechanical engineering students, for XC students, and for civil engineering students also. So, uh, already I have covered one lecture, that is first one. There is no link between that and this. It is a series of questions wherein there is no link between first lecture, second lecture. ऐसा कोई link नहीं है. So if you have not watched the first class, I have covered 4 questions. So this is the second class in continuation to that. But you don't have to see first, all questions are different questions. So I'll try my level best to include each and every variety. Chalo. You can watch this class independently without looking at the first class. If you want, you can see the first class also. There is no problem at all. Chalo. Let's take this. Let us start with a simple question. A 150 mm diameter solid steel sphere is lowered into an ocean to a point where the pressure is 50 megapascal. See, the pressure is given as 50 megapascal. Okay, no problem at all. The pressure is 50 megapascal. And the Young's modulus is given, Poisson's ratio is given. Which of the following statements are true? He is asking about decrease in diameter. He is asking about decrease in volume. Chalo. So what is the diameter of the sphere given? Let me check. The sphere diameter is 150 mm. Okay. Chalo. And Young's modulus is 200. Poisson's ratio is 0.3. Young's modulus is 200 into 10 power 3. It is given in gigapascal, so I have converted in megapascal. And the Poisson's ratio is 0.3. Let me check once. The Poisson's ratio is 0.3. Now, see, this is the free surface, okay, and it is lowered. And he said it is subjected to a pressure of, this is nothing but, it is subjected all round. So what is the pressure given? I think it is given as 50 megapascal. Okay. So this is the case of hydrostatic condition. So if you draw a Morse circle, it will be a point on the negative x-axis. Okay. Right. This is the situation. If I take a small element, my dear students, if I take a small element of sphere, so we have this pressure, which is 50. We have this, and all round it is sphere, a three-dimensional one. So here, if you take a small element, everywhere it is subjected to 50. So I will write this as sigma x is equal to, because there is a sphere, it is lowered. So x, y, z. So I repeat, sphere, x, y, and z. So therefore, sigma x is equal to sigma y is equal to sigma z is equal to 50. Now, we know that the diametral strain already, in this case, it is symmetric about x, y, z. So I can say that sphere has infinite symmetry. But you cut along any diameter, it will be symmetric. So there is no problem. So if you want this, for example, epsilon x is equal to sigma x by e minus nu by e into sigma y plus sigma z. In this case, whether it is epsilon x or epsilon y or epsilon z, all are same. So therefore, I will write this as x is diameter, y is diameter, z is also diameter. So this is nothing but your diametral strain. I repeat, x direction, there is a decrease in diameter. Y direction, there is a decrease in diameter. Z direction, there is a decrease in diameter. So in this case, epsilon x, epsilon y, epsilon z, all are same. So therefore, I will write this as, this is 50, these are all 50. So I will take sigma, let us say sigma x, sigma y, sigma z. Let it be equal to P. So sigma x, sigma y, sigma z, all are P. So I will write this as P. This is P. So sigma x is P. This is P. This is P. P plus P is 2P. So P by E, let me take common. So if I take P by E, P plus P is 2P. P common. So P by E 1 minus 2 nu. Exactly. So therefore, the diametral strain is given by, one more thing, both should be in same units. So P is in megapascal and Young's modulus is also in megapascal. That is 50 by 200 into 10 power 3 into 1 minus 2 into the Poisson's ratio is 0.3. Let me check. Is it 0.3? Yeah, it is 0.3. So if you calculate, I think the diametral strain we have already calculated. So the diametral strain is 10 power minus 4. Strain is dimensionless. So it is change in diameter to the original diameter. But actually it is compressive because sigma, this is negative. I have not taken negative because all are of same nature. When all are of same nature, there is no need to take why? If you take minus, this will be minus and this minus will be common, it will be same. So therefore, so what is happening? There is a reduction in diameter. So actually, this is minus. This is minus. Why? Because, look at, can I write? Pressure is always compressive in nature. If it is compressive, it will be minus. So the diametral strain is given by minus 1 into 10 power 4. So therefore, change in diameter is equal to minus 1 into 10 power 4 into diameter. What is the diameter given? 150 mm, if I am not wrong, 150 mm. So the change in diameter is equal to, it is 15 into 10 power minus 3 mm. Correct na? Is it correct? Yeah. Or this can be written as 15 into 10 power, milli को 10 power minus 3 लिखेंगे, minus 6 meter. अरे यार, millimeter to meter. So it is reduction. The negative sign shows there is a reduction of diameter. So it is by 15 micron or 15 micron. There is a reduction in diameter of 15. Let me check the value. So decrease in diameter is 15. Decrease in diameter is 15 into 10 power minus 6. Now, it is a MSU question, a multi-select question. So we have to calculate the change in volume. For a sphere, you know, the change in the volumetric strain is given by, I repeat, 3 times the diametral strain. Why, sir? Sigma x, sigma y, sigma z are all same. So what is volumetric strain? Sigma x plus sigma y plus sigma z. In this case, sigma x, sigma y, sigma z all are same. Therefore, I wrote this. So the volumetric strain is given by 3 times. And the diametral strain, just now we have calculated, minus 1 into 10 power minus 4. Already we have calculated. So the diametral strain is minus 1 into 10 power minus 4. Very good. So the volumetric strain is given by change in volume to the original volume, that is minus 3 into 10 power minus 4. So the change in volume is given by minus 3 into 10 power minus 4 into volume. So therefore the change in volume is given by minus 3 into 10 power minus 4. What is the volume? 4 by 3 pi. But the answer is given in meter. Volumetric change is given in meter. So let us keep diameter. It is a sphere. So the volume is, initial volume is given by, so therefore change in volume, change in volume is equal to this into original volume, 4 by 3 pi r. What is the radius? The diameter is 150. So radius is 75. But 75 is in mm. Convert in meter. 0.075 whole cube. Let me repeat, sirs. 150 mm is the diameter. The volume of sphere is 4 by 3 pi r cube. Radius is 75 mm because the diameter is 150. 75 mm is 0.075. So the negative sign shows reduction in volume because it is compressive all round. So I think you are getting this as 5.3 into 10 ki power minus 7 meter cube volume. So negative sign shows decrease. So this can also be written as 530 into 10 power minus 9 meter cube. Where is that? 530 into 10 power minus 9. Yes. So options are B and C. Should be correct. Let me check once. Let me check once. कहाँ गया रे? B and C. Where is that? Yes. Next question. Next question. Now, this is a good question. Check करो. A rigid bar AD. A कहाँ गया? AD is supported by two steel wires of 1.5. These are two steel wires and the diameter of both wires is 1.5 mm and Young's modulus is given and a pin and a bracket at A. Achha, yahan pe. Okay, there is a bar, rigid bar is supported by hinged here and supported by two steel wires. Okay, right. Initially they are taut, matlab tight hai initially. When 1 kilonewton, this load is given as 1 kilonewton. Observe clearly. A load of 1 kilonewton is applied at point D. This is point D. And which of the following statements are true? एक बार देखना. टेंशन इन द वायर बीई पूछ रहा है, टेंशन इन द वायर सीएफ पूछ रहा है, करस्पॉन्डिंग डिफ्लेक्शन ऑफ पॉइंट डी, इसका डिफॉर्मेशन पूछ रहा है, हाउ मच इट इज डिफ्लेक्टिंग एंड ओके. So we have to find out tension in this, and the deflection of this. So let me do this question, sirs. कहाँ गए रे वो? Yes. Let me draw the figure first. This is hinged. Right. And now, there is a load of P. How much is that P? And this is given as 1 kilonewton. So I'll write it as 1000 Newton. Okay. So you know, my dear students, when the load is applied, it should move down, but it is not moving down. There are supports by wire. So therefore, this I'll write it as F. The wire is given as FC. So this is CF wire. Okay. And the other is BE wire. So this is BE wire. That is FBE. Excellent, sirs. FBE. Okay, na? And please note down clearly. This length is given as 300 mm. This is given as 300 mm. And this is given as 300 mm. All are 300 mm. All are 300. All are 300. All are 300. See, I have not shown reactions here because they are unknown values. So if I take moment at this point, let me take this as A, और इसको हम B मान लेंगे, इसको C और इसको D मान लेंगे. Look at, just observe, my dear students, the length of this is given as 250. I repeat, BE is given as 250 and CF 250 plus 200. This total length CF is given as 450. 250 plus 200 is 450 and BE is 250. चलो कोई बात नहीं. तो I will write the length of BE is given to us as, how much is length of BE? It is 250 mm. And the length of the CF is 250 plus 200, that is 450 mm. All lengths are given. Now let us find out tension in this. Very simple, sir. बहुत ही simple है. कुछ नहीं है. Take moments about this point, because as the system is in static equilibrium, net moment about any point is zero. For convenience, I will take moments here so that the moments due to reactive forces, these hinge reactions will vanish, because I am taking moments about this point. So this is causing anticlockwise, this is causing anticlockwise. Total anticlockwise should be equal to total clockwise. So I will write this as 1000 into 300 plus 300 plus 300. It is 900. I have taken this 1000 in Newton. This is clockwise. Should be equal to anti-clockwise. So FBE into 300. Okay. This is FCF into, देखो FBE into 300. FCF into 300 plus 300 is 600. Plus FCF into 600. Let me repeat, sirs. This is clockwise, anti-clockwise, FCF into 600, FBE into 300. So I think 300, 300, 300 can be cancelled. So therefore 300, 300, 300 twice, 300 thrice. So 3000 is equal to FBE plus 2 times FCF. This is equation number 1. And one more thing. Now observe clearly. So as there is an external load, एक बार देखना sirs, as there is an external load like this, finally it will deform something like this. Finally it will deform like this. So this is the deformation of CF. This is the deformation of BE. So therefore the final figure, let me show. कैसा show करेंगे यहाँ पे? कोई बात नहीं sirs. Let me show here. Okay. The final deformation is something like this. And this is the displacement of point D. I think he is asking this. So let me write it as delta D. And this is delta, look at CF. And this is delta BE. Very good. This is 300. This is 600. And this is 900. All are given. So directly I am writing this is 600, 300 and 900. So can we write delta BE by 300? Similar triangles. Vertical length by horizontal. Vertical length by horizontal. Vertical length by horizontal. So I will write this as delta CF by 600 is equal to delta D by 900. No problem at all. So from this I can write delta BE is equal to, this is 2 and this is 3. 301s, 302s, 303s. So delta CF by 2 is equal to delta D by 3. So in the problem he is asking what is delta D. So in order to calculate delta D, either you find out BE, deformation in BE or CF. But देखो एक बार यहाँ पे I have this particular equation. Now one more thing. तो can I calculate the there is a relationship between, देखो ये लेके next slide पे जाना. Delta BE is delta CF by 2. Delta BE is delta CF by 2. Delta BE is delta CF by 2. By 2, there is by 2. So I will take on to this side. It is by 2, so I'll take. So 2 into, what is the deformation? PL by AE. P, length of BE by area of BE, E of BE should be equal to deformation of CF. Load in CF, P, L by A, E. I repeat, sirs, I repeat. PL by AE, deformation is PL by AE, actual deformation. This is PL by AE. Ab dekho. Now, I think both are made of same material if I am not wrong. Ek second, dekho ek bar. So both wires are of same diameter, so area will be same, and both are steel wires, so Young's modulus is also same. So luckily the area and Young's moduli are same, so I can cancel out this, no problem at all. Twice of F, because both are of same diameter, so area will be same. Both are of same material, so Young's modulus is same. This gets cancelled out. FBE into LBE is equal to FCF LCF. So 2 times FBE. What is the length of BE? What is the length of BE? Length of BE is 250 mm. It is 250 mm. FCF into length of CF. What is the length of CF? 450 mm. Okay, this is 450 mm. Absolutely. So this is in mm, this is in mm. So no problem at all. So I think we can write FCF is equal to, if you want this 450 will come to the side. 2 into 250 is 500. So it is 500 by 450. FCF, 500 by 450 into FBE. Absolutely no problem at all. 50 tens, 50 nines. So therefore, FCF is equal to 10 by 9 FBE. Already you have one relationship between CF and BE. CF and BE. CF and BE, CF and BE. So therefore, already I have this relationship. 3000 is equal to, so क्या equation था sir यहाँ पे? FCF is 10 by 9 FBE. FCF is 10 by 9 FBE. FCF is 10 by 9 FBE. So everything is known except FBE. अरे यार ये तो simplification है. तो if you calculate, I think you are getting FBE as, एक बार चेक करना. If you calculate, चलो, do you want me to calculate? FBE is FBE. तो FBE आ रहा है 0.932 something F, but F is given in kilonewton. So already P is given. This P already this is 3000 now already ये P में आ रहा है. So if you calculate this value, my dear students, I repeat, अगर आप इस values को calculate करेंगे, if you calculate FBE, you are getting this as some 933 or something like that Newton. So FBE is 933 Newton. And similarly, if you calculate FCF, what is FCF? FCF, यहाँ पे equation दिया देखो. What is FCF? FCF is 10 by 9 FBE. 10 by 9 FBE. एक बार देखो. 10 by 9 into 933. So this is 1036. This is 1036. So therefore, yes, tension in the wire BE, CF, both are correct. A and B are correct. अभी देखते हैं sir. It's not over. So please observe here. एक second. Tension in the wire B is 933. This is 1034. CF is 1034. Now corresponding deflection of point D, इसका deflection चाहिए. Check करते हैं sir. So I think if I calculate delta BE, the problem can be solved. So what is the force in BE? 933 Newton. So 933 Newton. So therefore, delta BE is equal to force in BE, length in BE by area of BE and Young's modulus of BE. Yahan se you have to be very, very careful. So we can calculate, and already we got this force as how much? Just now we have calculated. The force in BE is 933 Newton. What is the length of BE? Already you know. The length of BE is, ek baar dekho, 250 mm. This is 250 mm divided by area. What is the area? One more thing, sirs. Length in mm, area in mm square, E Newton per mm square. So you will get this delta in mm. So what is the diameter given, sirs? The diameter of the wire is given as 1.5. एक बार check करते हैं, sir. 1.5 exactly. It is 1.5. So therefore, it is 1.5 square, and the Young's modulus is 200. कुछ होता है स्टील का 200 gigapascal. So therefore, it is 200 giga means 10 power 3 megapascal. So if you are calculating, you will get delta BE as 0.658. ये आ रहा है 0.658 mm. But I don't want the deformation of point E. देखो इसका नहीं चाहिए, BE का नहीं चाहिए. I want D. So already you know the relationship. What is that? Delta D is equal to 3 times. I take this to the side. 3 times delta BE. Delta D is equal to, so if you want the deformation of the 3 times of this, 3 into 0.658 mm. So I think I'm getting the answer as 1.978 or something like that. So many mm. So therefore, the answer is 1.978. Correct. This is the right answer. So A, B, D are the right answers. A, B, D should be correct. Wonderful, sir. This is my answer. Is it okay? Now let's move to the next question. Next question is a very good question. Take this question. Please read the question. Read the question. Come on, come on. The post is made of Douglas firewood. Okay, ye wala. This one. This is the post, vertical one. And has a diameter of 100 mm. This ये बहुत ही अच्छा सवाल है, sir. So it has a diameter of 100 mm. Okay. If it is subjected to a load of 20 kilonewton and the soil provides a frictional resistance, there is a post we are keeping like this. The soil is offering resistance. This is the resistance. So when there is a load like this, the resistance is upward direction. The soil is offering resistance like this. Okay. And that resistance is varying, oh God, along its length will vary linearly with W is equal to 4 kilonewton meter per meter at Y is equal to 0. I'll explain, don't worry. I'll explain everything. At Y is equal to 0 means Y is measured from here, Y is measured from here. So this is Y0. Here, the resistance is 4 kilonewton per meter length. And slowly when I'm moving down, the resistance here at Y is equal to 2. The total depth is 2 meter. Total depth is 2 meter. Here the resistance is how much, sir? 12 kilonewton per meter. And neglect the weight of the post, iska weight. So which of the following statements are true? Ek second. Let me explain the question. पहले question को समझो, sir. First you try to understand the question. Let me explain. This is the post. I repeat. This is the post. Its diameter is given as 100 mm. Now we have applied a force like this, okay. Now the soil, the surrounding soil is offering a resistance, frictional resistance. But unfortunately, the resistance is not constant. So here the resistance is at Y0. So Y is measured from here. So at Y is equal to 0, the resistance is 4 kilonewton. And slowly when you are moving down, the resistance, actually the post is like I have applied a force like this, like this, like this, like this. So when it tries to move like this, resistance will be, soil resistance will be in the upward direction. Here the resistance is 4 kilonewton per meter. And here the resistance is 12 kilonewton per meter. And clearly he said it is varying linearly. Okay, no problem. Neglecting the weight of this. So क्या बोल रहा है? What is the force at the bottom? क्योंकि क्या होता है देखो. When there is a downward force, when there is an upward force, there is a resistance, there is a resistance. So he is asking what is this net force? Apart from this, what is the displacement of top of this? ये कितना displace होगा? ये कितना displace होगा? Let me do this question, sir. First, I will explain the question. Then we'll try to solve the question. Let me explain. Actually, this is the post. Its diameter is given as 100. Now there is a load applied and that is 20 kilonewton. Wonderful, sirs. And there is a resistance. When you are applying a load like this, the soil, surrounding soil, kahan gaya re? The surrounding soil is offering resistance like this, but that resistance is varying with length. So y is measured from here. यहाँ से measure कर रहे हैं y. So here y is 0. At y is equal to 0, what is the resistance? At y is equal to 0, it is 4. Just I am showing, actually the resistance is in this direction, but I am showing, let the resistance be 4. इधर देखो, ध्यान से देखो. Here the resistance is 4. And at a depth of 2 meter, what is the resistance? It is 12. Given this is 12. Excellent, sirs. And it is varying linearly. इसका physical meaning क्या है? If you see, here the resistance is in upward direction. Here the resistance is 4 in the upward direction. And here the resistance is this much. And here the resistance is at the bottom, it is 12. So it is varying linearly. एक काम करते हैं, sir. At any distance y, we'll calculate this. तो can I write this as, इसको 1 second के लिए, dear students, इसको 1 second के लिए w ले लेना. But only this much, only this part, only this part, only this part, only this part. I repeat, only this part को w ले लेना. So what will be the resistance? This 4 at any depth y, it will be, देखो, common sense देखो. मैं इसको मिटा दूंगा, sir. Now, observe here. What is this given? It is 12. So can I write this as, this is 12, this is 4. So what will be this, my dear students? ये 12 है, ये 4 है. तो ये कितना होगा? 12 minus 4, this will be 8. So let us take similar triangles. We will take similar triangles. कैसे similar triangles? 8, this total length is 2. This total length is 2. Can I write from bigger triangle? This is the bigger triangle. ये वाला. This bigger triangle. Can I write 8 by 2 is equal to 8 by 2 is equal to, अरे horizontal by this vertical is equal to this by this. तो ये कितना होगा? W by y. I repeat, sirs. This is one smaller triangle. ये triangle. So W by y, similar triangles. W by y is equal to 8 by 2. 8 by 2. So is it clear, my dear students? अरे यार, it is something like this. This is 8. Correct? This is W. This is y. And this is 2. So ये क्या होगा? W by y, similar triangles. W by y is equal to 8 by 2. Wy is equal to 8 by 2. So what will be W? It is 4y. So I want the total value. ये तो already 4 है and this is small w. So total at any depth y, the resistance. So at any depth y, the resistance is, soil resistance is, at any depth y, the resistance is this 4 plus w. So is 4 plus w is 4y. एक बार cross check कर लेना. When y is 0 है, तो resistance कितना होगा? 4, correct. When y is 2, 4 to 8 plus 4, 12, correct. At any distance y, this is the resistance. Exactly. अब carefully देखो. So at this position, the resistance is given by, at this position, the soil resistance is given by, at any distance y, मैं नया स्लाइड ले लूंगा सर, अच्छा होगा. So look at, ये फिक्स्ड है. There is a load of 20 kilonewton and we have applied a vertical force F, है ना? Okay. Now at any distance y from the top, what is the resistance? यहाँ का resistance, थोड़ा color change करता हूं सर. Here the resistance is, already you know, at any distance it is 4 plus 4y. Excellent. Is the resistance constant or changing? The resistance is changing with, I repeat, the resistance is changing with y. क्या करेंगे सर? I will do one thing. The resistance is changing with y. एक काम करते हैं. You take small length dy. But clearly he said, be careful, my dear students. यहाँ पे देखना. See the question properly. It is resistance per meter length. So you are getting this resistance as per meter length. तो इट 1 मीटर के लिए इतना रेजिस्टेंस है, बट इट इज वेरिंग विथ वाई. If I vary y to a larger extent, this will also vary. So that's why I have taken small change in y. So this I call it as dy. So can I say here in this small length, what is the resistance? So it is per meter length. इसका length dy है, so it will be 4 plus 4y into dy. Exactly. Very good, sirs. ये होगा आपका resistance. Now let us calculate the total. This is the resistance in this. I want the total resistance. तो टोटल रेजिस्टेंस के लिए क्या करेंगे सर? ये तो ये छोटा लेंथ के लिए है, ये छोटा लेंथ के लिए. फॉर द स्मॉल लेंथ दिस रेजिस्टेंस. इफ आई वांट रेजिस्टेंस फ्रॉम 0 टू y, तो यहां से यहां तक टोटल रेजिस्टेंस क्या है? सो सी इफ यू वांट टोटल रेजिस्टेंस, आई विल इंटीग्रेट दिस. तो अब देखो, सो टोटल रेजिस्टेंस विल बी इक्वल टू, दिस इज द रेजिस्टेंस इन स्मॉल लेंथ dy. टोटल चाहिए तो क्या करेंगे? इसको इंटीग्रेट करो. कहां से? y इज इक्वल टू 0 टू y इज इक्वल टू 2. तो टोटल रेजिस्टेंस इज इक्वल टू 4 प्लस 4y इंटू dy, दैट इज 0 टू 2. इंटीग्रेट करो. सो देयरफॉर 4 dy इज इंटीग्रल dy इज y प्लस 4 y dy इज y स्क्वायर बाई 2. y dy इज y स्क्वायर बाई 2 एंड इट इज 0 टू 2. तो कितना आ रहा है सर? 4 इंटू अपर लिमिट इज 2 plus this 2 is gone, 2 into y square, 2 square. So 4 into 2 is 8, 4 into 2 is 8, 16. So the total resistance is kitna aa raha hai sir? 16 kilonewton. So observe clearly, he is asking how much force is required to apply. So the total resistance, soil resistance is 16 aa raha hai, soil resistance 16 aa raha hai, plus this force is F, ye F aa raha hai, plus there is 20 kilonewton load. Up sum of the downward is equal to sum of the upward. The total soil resistance is 16. ये upward होगा. This F plus 16 is total upward, should be equal to total downward. So therefore the total resistance is 20 minus 16. It is 4 kilonewton. Please tell me, is it clear, sirs? This is a wonderful question, sirs. So the total resistance required is, कहां गया रे वो? कहां गया? The total force F at the bottom is, I got it as 4. तो 7th question का आंसर देखेंगे. Yes, B is the right answer. B is the right answer. Problem is not over, sirs. Problem is not over. और क्या चाहिए आपको? He is asking the displacement of the top. मतलब because of this force, how much it is displaced? How much it is displaced? He is asking. ये तो बहुत सिंपल है सर. मैं आपको बताऊंगा सर. Such questions can be asked. Be careful. Let us take. This is the force 20 kilonewton at any distance y. What is the resistance? हम सिर्फ यही ले लेंगे सर, सिर्फ यही ले लेंगे. I will cut this, ये सेक्शन, ये वाला सेक्शन XX कट करके ले लेंगे. And there is a resistance, soil resistance कितना है सर? There is a soil resistance 4 plus 4y, correct ना? 4 plus 4y is the soil resistance per meter into dy. Very good. एक सेकंड, कहां गया वो? हाँ, एक सेकंड. 4 plus 4y dy is the resistance. Absolutely fine. No problem at all. 4 plus 4y dy is the resistance. तो अब मुझे बताओ सर, can I calculate? Listen carefully. 4 plus 4y dy is in the small length dy. It is, देखो, at any distance y, किसी भी distance y पे, I repeat, किसी भी distance y पे, I got 4 plus 4y. But this is per meter. But this is varying with y. So I have taken in a small length dy. In a small length dy इतना होगा. Great. अगर आपको यहां से लेकर y02, let us say this is y. So if I want the total resistance, there is 20 kilonewton. If I want the total resistance, क्या करेंगे सर? यहां से यहां तक इसको इंटीग्रेट करेंगे. I will be integrating this. I repeat, sir. From the top to y, from the top to y distance, what is the total resistance I'll be calculating? From the top to some y, arbitrary distance y. तो from the top to this y, कितना resistance है कैलकुलेट करेंगे. तो already you know in a small and dy इतना है. तो from here to here I'll integrate 0 to y. So इसको इंटीग्रेट करना. 4y, integral dy is y plus 4y square by 2. This will be equal to 4y plus 2y square. What is this, sir? I have integrated this from 0 to y. इसको हम 0 to y इंटीग्रेट किए. For example, 4 plus 4y into dy, it is the resistance in a small length dy, but I want in this length ये पूरा resistance चाहिए, तो क्या करेंगे, इसको इंटीग्रेट करते हैं 0 to y. So therefore 4 dy is y plus 4 y dy is y square by 2 and integral limits are 0 to y. तो कितना आएगा सर, 4y plus 2y square. What is the meaning of this? It is the total resistance up to this, या इस पोजीशन पे. Now you tell me, there is a downward force, there is upward force. What is the net force? Net force अगर हम ये देख रहे हैं, so the net force is, this is the upward force, ये upward force है सर. Please observe here, this is the upward force, this is the upward force and this is the downward force. Net downward force is equal to 20 minus ये force आ रहा है, so 4y minus 2y square. I repeat sirs, you might not have followed. Actually whatever you have calculated ना, it is the force or the resistance in small length. अगर मुझे टोटल इस लेंथ पे चाहिए एट एनी आर्बिट्ररी ऊपर से यहां तक चाहिए, तो 0 to y इंटीग्रेट करेंगे. दिस इज गिविंग मी रेजिस्टेंस फॉर दिस लेंथ. सो व्हाट विल बी द नेट फोर्स? देयर इज डाउनवर्ड, देयर इज अपवर्ड. तो प्लीज ऑब्जर्व, ये रेजिस्टेंस इज वेरिंग विथ y. तो मैं क्या किया, ऊपर से लेकर कुछ आर्बिट्ररी y तक आई हैव कैलकुलेटेड द रेजिस्टेंस. तो एट y द लेंथ ऑफ द पोस्ट y ले है, तो वहां पे 20 किलो न्यूटन है. यहां से कितना फोर्स ऐड करा है, 4y प्लस वाई स्क्वायर, 20 4y प्लस वाई स्क्वायर. तो नेट फोर्स क्या होगा, दिस माइनस दिस. वेरी गुड सर, दिस इज द नेट फोर्स. वेरी गुड, दिस इज द नेट फोर्स. तो ये नेट फोर्स आ गया. अब मुझे बताओ डिफॉर्मेशन क्या होगा. डिफॉर्मेशन क्या होगा, PL by AE, PL by AE. So therefore this force is varying with y. That's why what I do, this is the net force sir, this is the net force my dear students. I repeat, this is the net force and this is varying with y. That's why I will calculate this is the force at any distance y, this is the net force, this is the net force on this force at any distance y. तो it is varying with y, तो हम small y ले लेंगे सर. तो क्या होगा सर, deformation in small y is PL by AE. Why are you taking small y? Because it is varying with y. So P minus 2y square, PL, L को हम small y ले लेंगे, PL by AE and this will give me the deformation of small dy. अगर टोटल चाहिए तो कहां से इंटीग्रेट करेंगे, 0 से लेकर, टोटल पूछा है वो टोटल 0 से लेकर 2 तक, 0 से लेकर 2 तक. and here you have to be very careful with units. This 2 is in meter. तो let us take all length dimensions in meter. प्लीज बताइए, आर वी क्लियर सर? ये थोड़ा अच्छा क्वेश्चन है सर, दो बार इसको इंटीग्रेट करना पड़ रहा है. सो लेट मी एक्सप्लेन, बहुत केयरफुली देखो. P net force is P, L by AE. I have taken small length. अब देखो, now you know the area. What is the area sir? It is 100 mm दिया है. एक सेकंड, look at. हाँ देखो, these are all very good questions sir. Integral 20 minus 4y 2y square, 4y 2y square into dy by area, pi by 4, the diameter is 100 mm, d square. I am taking in meter because already this 0 to 2 is in meter, तो ये भी per meter था, so this is per meter था, so I have taken all in meter. E, what is E? What is E? It should be Newton per meter square. What is E given? अरे कहाँ गए रे, E कितना है सर? Somewhere it is given. E is given. कहाँ गया रे? हाँ, E is given as 13.1 gigapascal. E is given as 13.1 into 10 power 9 Newton per meter square. E is given 13.9 into 10 power 9 दिया है. E is 13.1 into 10 power 9 Newton per meter square. इस पूरे को इंटीग्रेट करना, you will get the deformation. You will get the total deformation of point B. So if you are calculating, I think you are getting this value as 20y minus 4y minus 2y square. Okay, यहाँ पे और एक मिस्टेक कर रहे हैं सर, आप बता सकते हैं आप? This is in Newton per meter square, but this load 20 is in kilonewton. ये किलो में है सर, किलो में है, तो इसको भी न्यूटन में रखना. तो into 10 power 3, this 20, all these loads are in kilonewton. तो किलो को 10 power 3 से मल्टीप्लाई करना न्यूटन मीटर. देखो, this is in न्यूटन, किलो न्यूटन को 10 power 3 से मल्टीप्लाई न्यूटन मीटर, and this area is meter square and Newton per meter square. You will get this delta in meter. If you calculate, integrate करो आप, ये भी मैं नहीं करूंगा सर. If I integrate this, अरे 20 into dy is 20y, 4y dy is 4y square by 2, 2 y square divides y cube by 3. अगर इसको इंटीग्रेट करेंगे you will get the value of delta, and that delta is nothing but 2.59 into 10 की power minus 4. 2.59 into 10 power minus 4 meter, or 0.259 into 10 power minus 3 meter, or 10 power minus 3 meter means mm. So 0.259 mm. It's actually compression. मतलब इसके respect से ये नीचे आ रहा है, मतलब minus compression. Compression, because of this load, it is getting compressed. So therefore, this is also a very good question. It's a very, very good question, sirs. Very good question. Let's take next question. Let's not waste time. ये लीजिए. Take this question. The stainless steel post A, okay, ये है देखो A, surrounded by brass. This is A. A stainless steel post A. ये वाला, solid. This is A. Surrounded by brass tube B. So this is brass tube B, surrounded by ये वाला brass tube B. Both rest on a rigid surface. Okay, a force of 25 kilonewton is applied on the rigid cap. The required diameter of the steel post so that the load LOAD is shared equally between post and tube. Okay, E of steel is given, E of brass is given. एक second रुको. It is a composite section, sirs. Now, when I apply load, the load is shared between steel and the surrounding brass wala. But in this problem, he said the load is equally shared. So can I write the load applied is equal to load shared by steel plus load taken by brass? Exactly. But in this problem, both are equally shared. So applied load agar 25 hai, so this is PS. Brass is also same as PS. So both are coming out to be 12.5. He only said, I am not saying, sirs. He only said the load is equally shared. And he is asking what is the diameter of this. कुछ नहीं है सब. अगर composite section है, तो under the load, whatever the steel is deforming, the brass should also deform by the same amount. So I will write, देखो रे, this is the steel. Okay. उसके बाद यहां पे there is brass. आराम से टेंशन मत लेना सर्स. दिस इज द कैप. इस कैप पे लोड अप्लाई किया. थोड़ा कलर चेंज करूंगा सर्स. आई विल चेंज द कलर. दिस इज द स्टील. ये वाला स्टील है. इसका डायमीटर पूछा है. लेट द डायमीटर बी डी एंड सम मोर डायमेंशंस आर गिवन. थोड़ा देखो. दिस इज गिवन एज 150. 75 mm outer radius दिया है. From the axis, the outer, this is brass वाला. देखो ये brass वाला, and the thickness is given as 12 mm. फिगर ठीक तरह से नहीं दिया तो ये 12 है. तो my dear students, can I say the outer diameter of the brass is 150 mm? ये 150 दिया है. तो what will be the inner diameter? देखो एक सेकंड रुकना. So the outer diameter is, this is the outer diameter. ये देखो ये brass का outer diameter ये 150 है. तो inner diameter will be this one. देखो एक बार, inner diameter will be this one. ये वाला inner diameter होगा. तो how can I calculate inner diameter? So 12 निकालना. This thickness 12, this thickness 12 निकाल देना. तो क्या होगा? The inner diameter will be equal to outer diameter minus 2 times thickness. I repeat, sirs. इधर देखो रे, क्या students है आप भी, नमूने. Let us take only brass वाला ले लेंगे. इधर देखो, only brass. This is the brass. This thickness is 12, this thickness is 12, and the outer diameter is 150. So if the outer is 150, what will be the inner diameter? ये वाला. If you want the inner diameter, it will be 150 minus 12. So inner diameter is equal to outer diameter is 150. एक second. Outer diameter is 150 minus 2 times the thickness is given as 12. So the inner diameter will be 12 to 24. 150 minus 24 is 126 mm. हो गया सर. Brass का outer diameter is 150, brass inner diameter is 126, and steel diameter, let us say ds. तो क्या है सर? So when there is a load applied, both deforms to same extent. It is a composite section. So deformation of steel is equal to deformation of brass. Very good. So deformation is PL by AE in steel must be equal to PL by AE in brass. Very good. What is the length of both? Same length. And clearly ये बोला है equally shared. The load is equally shared. So load in steel PS, load in brass PB. He only said same. तो काट देना. and lengths are also same, ये भी गया. तो area of steel, E of steel is equal to area of bronze, E of bronze. Excellent, sir. What is the area of steel? It is solid, pi by 4 d square. And E of steel, diya hai, sir. What is E of steel? E of steel is 193. E of brass is 101. 193, 101. Both are in gigapascal. 193, 101. 193, 101. 193. Brass का क्या होगा? Brass is hollow. Outer diameter square minus inner diameter square into 101. Don't worry about the unit. Gigapascal, gigapascal. ये होगा. So everything is known to me. ये निकाल देना. So you will get the value of कितना आ रहा है सर? ये 101 है. So you will get the steel diameter as, I think I got the steel diameter. कहाँ गया रे वो? 58.8 if I am not wrong. 58.8. 58.8 mm should be correct, I think. 58.8 mm. Is it correct? Yes, yes. Let's take the last question. Let's take the last question, 9th. ये वाला लीजिए. The column is constructed from a high strength concrete and 4 steel rods. These are steel rods. ये देखो, ये एक rod, 2 rod, 3 rods, 4th rod. If it is subjected to an actual load of 800 kilonewton, the diameter of each rod, so that 1/4 of the load is carried by steel. So what is the total load, external load applied? It is 800 kilonewton. And how much is the load taken by steel? 1/4 बोला है वो. एक सेकेंड, क्या बोला है? 1/4 of load is carried by steel. 1/4 is carried by steel. So steel is taking 200 kilonewton. Already it has 10 power 3 newton. Okay. So how much is the load taken by concrete? अरे यार, 3/4 is taken by concrete. So 3/4 is taken by of 800. So therefore the concrete is taking how much, sir? 600 into 10 power 3 newton. Absolutely fine. No problem at all. So total is 600 plus 200 is 800. No problem at all. क्या बोला है sir? Same question. What is he asking? The diameter of each rod. बहुत carefully देखो sir. The deformation in steel is equal to deformation in concrete because it is a composite section. PS LS by AS ES is equal to P concrete, L concrete, A concrete, E concrete. No problem. देखो, what is the length of both? देखो, steel वाला और concrete का length क्या है? Same है. Excellent. And if you keep this in kilonewton, Newton, कोई बात नहीं sir. And यहाँ पे problem होगा. Let the diameter of the steel be ds. So what is the total area? This total load is taken by 4 steel bars. So therefore PS by, so यहीं पे लिख देंगे सर. क्यों again why to waste our time? तो यहीं पे लिख देंगे. What is the load in steel? It is 200 into 10 power 3. Excellent. And what is the area of steel? देखो, 4 are taking 4 into pi by 4 ds square. I repeat, 4. Let the diameter of each rod be, steel rod be ds. So each rod has a area of pi by 4 ds square. But there are 4. Therefore 4 likha into es. What is E of steel? It is 200. So you may be wondering, sir, why are you keeping in gigapascal? If this is in gigapascal, I'll keep this in gigapascal. The units are matching. So therefore, what is the load in concrete? It is 600 into 10 power 3. And what is the area of concrete? Be careful. The total area is 300 into 300. The total, now I'm writing area of concrete. Area of concrete is 300 into 300. Galat. Minus 300 into 300 minus 4 times this each area. देखो, 300 into 300 is 9 into 10 power 4 में से steel rod का area निकालना. There are 4 rods. Each rod has pi by 4 d square. So therefore, be careful, sirs. The total area में से each one is pi by 4 d square. 300 into 300 minus this निकालना. So therefore, it is 300 into 300 minus 4 into pi by 4 ds square. Excellent. Into area of concrete into E concrete is 25. Very simple, sirs. ये कट जाएगा, ये कट जाएगा. 1 second please. और कुछ जाएगा, ये 200 गया. तो 1 by ds square कुछ है सर? पाई भी है ना. This 200 is gone. 10 power 3, 10 power 3, so on this 200, 4 pi d square is equal to, अभी कुछ बचा है सर, 25, ये 25, ये 20, तो 24 आ रहा है यहाँ पे ऊपर, 25 ones, 25 fours. This is 9, 1, 2, 3, 4 minus pi ds square. Excellent square. Excellent. So if I take this, एक second, am I calculating correctly? Yes, exactly. So therefore, if I take it to this side, and yes, सही है sir? Yes. So this will be, I'll take it to the new slide. So therefore, 1 by pi ds square is equal to 24 minus by 9, 1, 2, 3, 4 minus pi ds square. एक बार चेक करते हैं. Correct. So therefore, 90,000, 1, 2, 4 zeros, I think. 4 zeros, yes, 300. Correct, na? Minus pi ds square is equal to 24 pi ds square. Correct. You take it to that side. 9, 1, 2, 3, 4 is equal to 25 pi ds square. So ds square is equal to 90,000 by 25 pi. तो अगर आपको d चाहिए, एक बार मैं कैलकुलेट करके देखता हूं सर. It will be 90, 1, 2, 3 divided by 25. So 33.85 आ रहा है सर. So the diameter of steel is 33.85. Wonderful, sir. Thank you, my dear students. So I'll come up with many more such lectures, and please, if you are happy with these classes, if you want many more such classes, just leave a comment so that it encourages us. Thank you. God bless you. Bye-bye.